It's Thursday, the 28th of March 2024, and welcome to the Water Action Platform. There have now been 9 consecutive months where weather records have been broken around the world, and 2024 is going to be an El Nino year. As such, we are bracing ourselves for the coming months to bring, almost certainly, some of the most extreme weather that we have ever experienced. So with this in mind, today we have a focus on carbon. We're going to hear from Walter Kling, the president of the IAWD, the International Association of Waterworks for the Danube catchment area. We have an exciting technology showcase from Capture 6, and we have a story from a UK water company that's recovering heat from one of their service reservoirs so that they can warm a local housing estate. Now, all of this is only possible because the Water Action Platform is sponsored by these lovely organisations listed here. And today we're going to finish the broadcast with a story about carbon cycling from the oceans, which, if we are to successfully address the climate crisis, is without a doubt going to play a significant role. But we start, however, with a shout out for an event that's being held in Edinburgh, Scotland on May the 2nd. The event is the UK/China Sustainable Aviation Fuel Forum, and it's being organised by Union Energy, a sponsor of the Water Action Platform. It's supported by the Scottish Development International and the UK Department for Business and Trade. Now, the event's going to be co-chaired by 2 professors from Cambridge University, Professor Andy Sederman and Professor David Aldridge. Now, David may be known to some of you for his excellent work on how to control quagga mussels in the water sector, something that we should surely revisit in a future broadcast. Now, the ambition for this event, however, is to drive the development of a thriving green energy sector. Technology suppliers, prospective end users and investors are going to gather to create a collaborative platform which will facilitate knowledge exchange, industry partnerships and, of course, investment opportunities. This forum will attract a diverse array of participants from across many sectors, and hence the outreach here on the Water Action Platform. If you want to know more, please contact Christine at the email listed. Our next section is a sector expert interview, and I'm delighted to introduce Walter Kling, president of the International Association of Waterworks for the Danube catchment area, also known as the IAWD, which is surely wrong, because surely it should be the IAWDCA, or IDAWACA for short. Anyway, joking apart, Walter has been one of the wise guiding minds for the water sector for the past few decades. He has incredible insights and experience which he generously shares, and does so in a way which is uplifting and informative. Now, as you'll hear in a second, I met Walter at an event last year where we talked about water usage and how the water footprints of individuals need to be all-encompassing. It's not just about what you use in the shower or when you clean your teeth. Now, here's a segment from the discussion that we recently had.
Walter, wonderful to be here with you. Thank you for taking the time for this call. For those who don't know you, I think it's worth saying that you trained as an environmental engineer sort of 30, 40 years ago. You've then spent a whole career working around the Danube area, 37 years at Vienna Waterworks, and over 20 years with heavy involvement, in particular at the board level with the IWA, all of which we're going to talk about in a minute. But I wanted to start because when we last met face-to-face, it was in Singapore last year, and we had a fascinating conversation about water footprints. Walter, can you expand upon what we talked about when we last met, if you can remember when we last met back in June?
Well, first, Piers, many thanks for this invitation to join you in this conversation. And yes, beside my work for Vienna Water and maintaining the supply of the city of Vienna, it's been always in my interest to stay connected with the university and learn about latest results and researches. And one of these interesting things was that at the University of Life Science here in Vienna, there was the try to calculate a water footprint of people in average living in Austria. And the interesting thing is that we learned that your daily consumption is not only what you get from your supplier. Your daily consumption can be calculated in a way that it concludes your whole lifestyle: the food you eat, the things you buy, mobility, everything. It's a very complex try to do this, but it comes out, instead of talking about a water consumption of 135 liters a day by your supplier, you are using 4,700 liters per person just to get your clothes, to buy food, to eat, to go to restaurants, to travel, to do all the thing which is connected to your lifestyle. And I think it's worth to look at such researches. It might not be an exact calculation, but it gives you an idea about the range where we are with water consumption.
And of course, the key thing there is, like you say, it's not a precise calculation, but it's the order of magnitude. So it's going from 100 litres to 4,000 litres. Whether it's going from 100 litres to 2,000 or 100 litres to 8,000, it's a massive order of magnitude jump. And it's more than just what I'm using in the shower. It's how much water was used getting my orange onto the plate that I then eat. I think it's incredible. And it was the only time I'd heard this sort of work going on, or at this level.
I think also one of the interesting points of this study that in average, 70% of this water consumption you're dealing with is happening outside your country. So only 30% is a consumption related to the environment you're living in. The rest is something you produce with a water need outside even your region, different continents. So, and to have this in mind gives you probably a little bit different thinking of how to deal with resources. And we discussed this with kids. We discussed this with adults, just to give them a sense of how important water is. And we will have now in March World Water Day a good reason to think about it.
Excellent. Well, and of course, we're used to talking about Scope 1, Scope 2, Scope 3 emissions with carbon. It's the same thinking that we now should apply to water. You know, the Scope 3 emissions of what's embedded in the infrastructure we build when we build carbon, when we're talking carbon footprint, we should think about that same embedded water footprint on the food we eat, the clothes we wear, the transport we take. Really interesting perspective. Thank you for sharing that. And that, just to be clear, that was from the University of Life Science in Vienna. That's where the main research came from.
In German called BOKU. It's always the short version for this well-known university. But if you go to the internet, you easily find the University of Life Science and this research here in Vienna.
Now, I said in the introduction that you spent 37 years at the Waterworks of Vienna, or Vienna Waterworks, I think it's officially known as. Tell me, 37 years, that's 1986, 87 to
Correct.
Give me a highlight and a low light. Give me one of both. I want a highlight and a low light.
Well, actually, I think professional life in water is more full of highlights. But just to give you an idea of the range, when I was still in the early 80s at university, I was proud to have a little Texas Instrument calculator to do my work. So this is when I went the first time to the office of Vienna Water. It was at the time where we had our first we had our first computers. So the whole range of digitalization, which we saw over the decades of 40 years now, happened in the sector and tremendously changed everything. We are much more efficient, we have much more knowledge, and we build on this knowledge. We still care about the resource of water and make it in the best way available to our customers. I think one of the critical points probably is when I look also to my work, which I do in the Danube region, and see the political change which we had in the early 90s when the Iron Curtain raised and the former communist countries moved into the middle of Europe, and suddenly economy, political circumstances changed. And this was a big challenge. This was lots of interesting.
You were 3 years into the role when the Iron Curtain fell, weren't you? 89.
This was 89 till 93.
Yeah,
and this was one of the probably more problematic points that I witnessed when former Yugoslavia broke apart, and suddenly you saw a civil war happening in this region, and you saw even on the second conflict with around the Kosovo with Serbia, you saw cruise missiles flying into bombing in Serbia and Belgrade, and I was so much aware that I will never see a war happening. And even when this happened, I was sure this might be the only one time. So don't be too scared. And looking what's happening now, this is really something which makes me much concerned. That is that the peace we had after the Second World War seemed to last forever. And I'm really wondering and disappointed that this is not lasting forever.
That's a sobering.
And it affects also our business with the association in the Danube region. We also worked in Ukraine, so we have been affected by the things happening in Yugoslavia. We've been affected by this, so this is something which touches me deeply.
As I said at the start, Walter has been a key guiding mind for the water industry, and he's played a leadership role in key organisations such as the IWA for many decades. He also happens to be one of the nicest people that you'll ever meet. Now, the key facts that I'm taking away from that interview is that, firstly, 70% of your water footprint comes from outside your region, and secondly, that your actual water footprint is probably 20 to 40 times bigger than you would think if you just took the reading from your local water meter. Walter, thank you for your input and your insights. Our next story is a really exciting industry case study. It relates to a new scheme to recover heat from a service reservoir and then use that heat to warm the homes of local residents. Now, to hear more about this, I spoke to John Pickford, Commercial Director at Portsmouth Water here in the UK. Now, I've known John for many years. Indeed, we used to work together at Thames Water 10 years ago. Back then, he was a tenacious man, always able to make those projects that appeared seemingly impossible to most people actually come to fruition. It was therefore a delight, but no great surprise, to hear about this particular groundbreaking project.
John, it is so good to be back with you. We work together very closely in Thames Water, and here you are, Commercial Director at Portsmouth Water. Tell me a little bit about Portsmouth Water.
Good morning, Piers. Portsmouth Water, beautiful little water-only company down here in the south of England. We're actually one of the oldest companies in the country as well. We were incorporated in 1857. We've got 300,000 customers, and we've got one of the largest collection of springs and boreholes in Europe in use down here in Havens.
Yeah, you sit on the bottom of the UK where all the water dribbles down the UK and it just gathers.
We get it all. So it's a big chalk aquifer. And it's actually a very exciting part of our history. Havant, as a town, was the home of paper and leather. In fact, the paper used for the Magna Carta was made here in Havant. So it's been a sort of water town forever. So it's a great place to be.
Okay, Portsmouth Water, small and beautiful. That's what we want. Portsmouth Water, small and beautiful. But before we get into this interview, I need to know a little bit more about you. And we like to ask a couple of cheeky questions. So let's jump in. What do you owe your parents?
Good question, Piers. I've been in the water industry for 20 years, and as you said, I've worked at Thames Water most of that time. My father was a farmer and an entrepreneur and a problem solver. So he would basically find the equipment, bits of string, rope, wheelbarrow. He could make anything out of anything. And I think that entrepreneurial love and sort of wishing to do a deal and to kind of make success from the materials you've got. Absolutely brilliant. Yeah, I think that's what I owe my parents.
Muck and brass and string and bits and bobs. That's how we're going to get it. I like it. Yeah. That's Dunkirk spirit for you, isn't it? And another one, when did you last cry?
So that's an easy one. So my daughter graduated last year with her diploma, and she's gone off to the world and got a job and living in a flat in Oxford. So yeah, as a family, we're incredibly proud of her and her sort of self-start and resilience. So that's like proper feeling going now. It's a proper moment actually to see your youngest child go out in the world. It's a big thing.
A new chapter begins. A new chapter. I just became a grandfather actually a month ago.
Oh wow! Congratulations.
Holding my newborn granddaughter, I couldn't help but the emotions just overwhelmed me. All right, we're here to hear about I think it's a world first, certainly at the scale that's being tried, of recovering heat from one of your reservoirs. Let's get into the detail.
Okay. It's a large service reservoir we have at a place called Hoax Hill, which is up on the top of a hill, which is quite a useful place for a reservoir. There's 68 megalitres, supplies about 100,000 people in Fareham and Gosport, and it turns over every 36 hours. So it's got quite a high in and out flows, which is what you need. And as I said already, most of our water comes from the chalk aquifer. And that sits at a nice sort of 12 degrees all year round. So you've got this huge body of water turning over regularly, coming in at 12 degrees. It's a fantastic opportunity, a fantastic resource. And we were approached about 3 years ago by Wellborn, who were the developers of a new garden village that's being built just literally to the south of the reservoir. I mean, it's perfect co-location. And that's about 6,000 new homes that are being built there over the next 25 years. And they approached and said, we think there might be something we could do here. We'd never heard of this technology before, really, on potable water, and the kind of 2 years later, here we are. We're digging holes. And
when they said something we can do here, they meant we think we could recover heat, or is it recovering cooling? Which of the two is it?
It's both actually. So originally, there's new regulations, new build regulations coming in. So new gas boilers will be outlawed from 2025. Yep. So they knew if they were going to build this estate over 25 years that they were going to have to do something different. And the original concept was to look at air source heat pumps or boreholes. And both of those are imperfect technologies, really. And so they saw this huge body of water from their satellite photos and thought, surely there's some opportunity here to utilise some of that asset that's out there.
Surely they thought, but it's the town of Shorley that they're serving, isn't it?
No, it's not. It's Wellborn Garden Village. It's actually okay. a whole new estate.
I've got my geography wrong. No great surprise. Yeah. All right. So physically, how does it work? How do they recover the heat?
So very simply, if you imagine a very large tank, we're going to take an outflow from part of that tank, take it to about 100 yards down to a heat exchanger that will pass through these a very clever bit of kit. Take out it's a very large body of water, but a very small amount of heat. So probably 1 to 2 degrees centigrade, so tiny bits of heat. But because there's so much water, that small change can obviously scale up to a huge amount of energy. And then the water will be returned back to the head of the tank, which will then get mixed in with new water coming in from the boreholes, and then go back into the tanks, and then ultimately into supply.
So there's lots of questions come bursting through now. Who owns the asset? Who operates the asset? Who takes the risk on it? What happens to the temperature in the reservoir? Let's start with that last one. What happens to the temperature in the reservoir?
So it's taken a long time and lots of modelling, because obviously what we can't do is take that temperature down to zero, because obviously that has a big impact on the wider environment and other consumers. So we've taken feasibility reports looking at different weather patterns, looking at different demand profiles, and ultimately with warm water coming in all the time, 24 hours a day, we don't see a material change in the temperature of the core body of the water. So that's the first thing to consider.
Sorry, as far as the assets, on the outflow from the reservoir, you think it will still essentially be at 11.5, 12 degrees C?
Because the water that's gone through the heat exchanger will then go back into a mixing chamber, or will get blended back in with the new water coming in. The proportion of new water coming in compared to the amount of water being put through the heat exchanger is very small. So yeah, overall, the whole mixing will make little difference.
Who owns the asset?
So the assets are all owned by Portsmouth Water, and they will adopt the piece of pipework that runs to and from the heat exchanger. So effectively, the water never leaves our network; it's within our control the whole time. The commercial arrangements are with a group company, but effectively, which does a number of different things around kind of insurance and protection. But effectively, the assets still remain within Portsmouth Water that are going to be processing the water.
Well, that sounds fantastic. Talk to me about timelines.
We are literally this week digging trial holes to look at the assets on the reservoir site, understanding where the points of the inflows and outflows are going to be. Planning is well advanced, procurement's well advanced. There's an expectation from the house builder we're going to be producing hot water and heating by September this year, which is really quite scary. And then that's the first 700 houses. That's the first phase of this. And then phase 2, 3, 4, 5, and 6 will continue the next 25 years. And ultimately, it'll be 6,000 houses. I think it's about 15,000 residents. There's a school, there's a hotel, there's going to be some medical centre, there's some commercial storage there. There's loads of stuff happening on that site. It's a proper village, actually. It's a beautiful project that we're really excited to be involved in.
Brilliant. Can you promise me something? In September, October time, can I come and see it? Can we do another little catch-up?
Absolutely.
Do that.
Yeah.
John, wonderful to hear. Portsmouth, small but beautiful and very dynamic. I know your chief executive, Bob. I know that he's been supporting you in making this game-changing example, and I'm sure others will want to follow. Thank you very much.
Fantastic. Thank you, Piers. Good to talk.
6,000 homes being heated, that's the ambition. Well, it may seem like a relatively small step if you're part of a big utility, but it's an important first step, and it demonstrates what can be possible. So well done, John. Well done, Portsmouth Water. Thank you for sharing, and I look forward to that visit later this year. We now come to our tech showcase, and this month it is Capture 6, an American clean tech company founded in 2021. Now, Capture 6 is at the forefront of affordable and scalable carbon capture technology. Their mission revolves around integrating direct air capture with electrochemical recovery of resources from desalination brines. They have a unique approach which addresses climate change whilst also producing valuable byproducts such as clean water, calcium carbonate for concrete, and lithium salts for lithium-ion batteries. Now, to hear more, here is Dr. Leo Park, Vice President of Strategic Development at Capture 6. Now, Leo also has a role on the UN climate change as a climate policy expert, and he's got a role as an adjunct professor at Inha University, teaching climate finance, sustainability management, and corporate climate change strategy.
So our journey started about 2 years ago, when we were founded to break this vicious circle, whereby climate change leads to more extreme weather events, and also especially water insecurity by creating a lot of drought across the world, which then called for more desalination and wastewater facilities to be added, which then eventually discharged more like brine into the ocean, which created the ocean acidity issues, and used a lot of the fossil fuel to power those facilities, which then again led to more greenhouse gas emissions and other environmental problems as well. So this is why we were created about 2 years ago to break the vicious circle, and then I'll show you how we are trying to address this. So next slide shows you our theory of a change, whereby, again, while we are doing the air capture in a very affordable manner to remove CO2 from the atmosphere, we can also do point source carbon capture using the solvent that we create. And then while we do this, we are trying to also address adaptation as well as mitigation, especially how we can address the water shortage issue, and then by using as much renewable energy possible, and also generating carbon negative byproducts. So basically, our process starts with the brine, which can come from, the wastewater treatment facilities, seawater desalination plants, as well as, the produced water. And then the next step is water treatment, and then followed by electrolysis or electrodialysis, depending on what kind of outputs that we want to produce. And what we need is the sodium hydroxide, which is a very effective ingredient, because once it's exposed to the ambient air, automatically binds with the CO2, and sodium carbonate, which is essentially the carbon mineralization process. And then we'll be using cooling tower air contactors to expedite the air capture process. And then once we have a sodium carbonate, we can then also do point source CCS, and then to capture additional CO2, and then the sodium carbonate will be converted into sodium bicarbonate. Or we can also blend it with the calcium, and then make it calcium carbonate. And all of this can be recycled, or can be supplied to other industry, or even better, stored underground or in the ocean, so that we can permanently sequester, capture CO2. And then what we do is, again, we can recover up to 75% of fresh water from brine reject, and then generate outputs that are carbon negative, and which can be also supplied to other industries. So next slide basically shows you, some of the examples how, our outputs can be supplied to decarbonize some of the heavy industries, like, the steel. So we are very, again, interested in not only removing CO2, but how we can make use of our outputs and byproducts, to help decarbonize the value chains of these heavy industries. Next slide shows you the global pipeline that we have managed to, develop so far, and then of course it's expected to be, grow further. And we show you some of the three, concrete examples. So this one is a Project Monarch, most advanced project. We are about to break the ground, and that this facility will be up and running in a couple of years. We're starting with a pilot, which can capture about 70 tons of CO2 per annum, but we are already in discussion with the Palm Water District, which is a project sponsor, to scale this up to 500,000 tons of CO2 capture facility of the next few years. And then we'll be using, again, tertiary brackish water from Palm Water District's water purification facilities. So just wanted to give you again an example whereby how we can partner with the wastewater treatment facilities. Next example, Project Octopus in South Korea, and this time we'll be partnering with again K-Water, which is the national water agency, and then they are building a large seawater desalination plant. So we'll be co-located with this facility, and then even at the pilot scale, we're about to capture about 1,000 tons of CO2 per annum. And we will be doing not only direct capture, but also working with the heavy industrial complex near the plant site, which emits about 17 million tons of CO2 per annum to the points of CCS. And the last one is a Project Wallaby in Australia, and this time we'll be using the produce water from Pilot Energy's facility, and then again we aim to scale this up to 640,000 carbon capture facility, and then which can also produce about 16.5 million tons of fresh water per year. Which is likely to be the largest, of a kind outside the US. The next slide shows some of the achievements that we have made. So we were the winner of the, Korea's International Water Week's World Water Challenge last year. And then, we are receiving a lot of grants, including 8 million from California Energy Commission, as well as the US DOE, New Zealand RRQ, and the Iowa Economic Development Board. And also we've been accepted by, prominent climate tech accelerators in the US, including Elemental Accelerator, Third Derivative, Carbon to Value, and Ocean Visions as well. And it's important to monetize, the carbon credits we generate, and we've been able to, pre-sell some of our credits to entities like TerraSet and Cacao Impact, and then have a, offtake agreement with the Respira International in the UK as well. So with this, I just wanted to really highlight, we definitely need all hands on deck, and then of course, we are also trying to address, the water issues in parallel. So I look forward to, again, continuing our conversations. Please, feel free to reach out to me anytime. And then, again, looking forward to having another further conversation with all of you. Thank you.
Well, thanks for that, Leo. Now, in addition to atmospheric carbon capture, Capture 6 is also actively working in ocean alkalinity enhancement, OAE, something which I've only learnt about recently, but I think is one of the most exciting and impactful areas for addressing the climate crisis. OAE involves dispersing alkaline substances into marine waters to increase their capacity to absorb carbon dioxide, while simultaneously counteracting the harmful effects of ocean acidification. OAE aids the restoration of vital marine ecosystems, such as coral and shellfish habitats, and it enhances the ocean's natural role as a significant carbon sink. Now, OAE is an exciting emerging field in climate technology, which we will definitely be exploring further in future broadcasts. And finally, we end with some good news coming from a recent study that stays true to this month's carbon theme and possibly even offers a way through the challenges. As you no doubt recall from your school science lessons, the ocean is a natural carbon biological pump. In summary, ocean life efficiently and constantly moves carbon from Earth's atmosphere and to the ocean surface and then into deep waters. The process is one of the Earth's natural carbon sinks, and we've known about this mechanism for decades. However, in classic and finally form, we are delighted to share with you a new development on this phenomena, which has been identified through a recent study. The study, with the rather catchy title Biological carbon pump estimate based on multi-decadal hydrographic data was published in Nature at the end of last year, with a veritable slew of authors as listed here. Now, the team behind this work had mapped the flux of organic carbon and nutrients within the biological carbon pump. They developed a new methodology for modelling the carbon cycle, which incorporates the hydrographic data collected by oceanographic research vessels across the globe since the 1970s. Now, the important bit in all of this is that the results show that the carbon fluxes and nutrient flows at a global scale on the level of detail that has never been previously seen. Now, the happy result is that they conclude that the deep ocean holds 20% more carbon dioxide than what was previously assumed and what was included in the latest IPCC report. Now, this tells us that the ocean is playing a larger role in atmospheric carbon sequestration than was previously thought, and helps fill in some of the knowledge gaps in our understanding of human impact on Earth. It is a small step in the right direction, and let's be honest, every step matters. With that, we come to the end of this month's broadcast. I once again thank today's contributors and, of course, our fantastic sponsors. The next broadcast will be on April the 18th, by which date many of you will have changed your clocks. So watch out if daylight savings thing is something that affects your area. Jo Burgess will be your host, and she has a really interesting update for you on long COVID, plus a groundbreaking technology trial where instead of pumping water into the air to aerate it, they pump water through air. Until then, keep asking questions, keep sharing, and keep safe.